Hello, everybody. Good afternoon. My name is Matthias Groschel from K2 Systems. I'm the country manager at K2 Systems since 2011, based in Slovenia. And today I'll be giving you a presentation about our excellent design software, K2 Base. I will be assisted by my colleague from technical service, Alessandro Lorefice, who will be also replying to your questions during the presentation, because I won't be able to do both. So we have over 42 participants today, which is always great to see how much interest we have in our excellent K2 Base software. Hope everybody is well in these challenging times. We're focusing very much on webinars, so a quick message for those colleagues of yours and maybe clients who couldn't, book this webinar. There will be several of them in the following weeks. So make them pay attention to our webinar schedule and let them apply. There will be a lot of them. We have a lot of interest, so a lot of seats are occupied. So these webinars are, overbooked very quickly. But don't worry, we will have several of them down the line. I have prepared 3 exercises today. 2 of them are from pitched roofs. One of them is from flat roofs. And before we hop into the presentation and the K2 Base itself, I'll ask you a quick question because I want to know how familiar are you already with K2 Base. I'm going to ask you a quick question. If you look down, you're going to see the question. So and I'm going to see the statistic right away. In terms of the questions during the presentation, you also have to look down and you see the questions section, and just write as the question in, and Alessandro, my colleague in the background, he will be following you. He'll be working on that, and he will be replying to your questions. So let me see these questions. Just waiting for these to, so you guys reply to my question. Okay, thank you very much. I suggest we, hop into the presentation. I will start with the introduction to K2 Base. First, I would like to explain to you a little bit of the icons above here. You also have the language section over here. We have about 16 languages in K2 Base. A lot of them will most likely follow, and you can choose your own language. For today's presentation, of course, we're going to use the English language. Here we also have the option for metric or imperial measure system, for US or for the UK. But for today's presentation, we're going to use the continental Europe metric system. First of all, the icons over here, left upper corner. Here you start with a new project. So you start a project from scratch, entering your parameters, building parameters, rooftop parameters, and you do this here. The icon over here is actually the open project. Let's say the projects that you have been already working on and you would like to change something, edit them, and you do this here. The icon over here is saving your project. And this icon, download project file, is basically downloading your project, let's say to desktop. You want to send the project over to me by email. You have to first download it, to, let's say, desktop, upload it in your email, and send it over to me. And the next icon here is help. It's pretty cool stuff. Let's say that you have a question to which you don't know the answer. You want to know, for example, what does the parapet mean, and it shows you like this what the parapet is, which is mostly for flat roofs. Then you know certain questions, a certain answer to questions will be also answered to you by as a video, for example here. So you can, you know, explore this a little bit, navigate through, and you'll see what everything is possible. Another icon here is called Sherpa, and Sherpa is basically an automatic technical support provided to you through either WhatsApp or Facebook Messenger, and it works by automatic answering. So provided somebody has already asked the question, it will be automatically replied to you. If not, then somebody from technical service will get back to you and reply to your technical question. For those who haven't, you know, if you want to encourage your colleagues, this is where you log in, first sign up, and then, you know, you have to register. You get the registration link, which you have to confirm, and this is where you also have to log in. Okay, another thing that I want to point out to and encourage you to use is also our K2 app. It's a very useful, cool tool, and it enables you doing the roof checklist. For example, you're at the job site. If you're an installer, you can be on the rooftop and you have to collect the parameters, do the building survey. You can enter this as a checklist in our app and save it. Later on, when you come back to the office, you'll be able to open these parameters, the data that you have saved previously on the job site, in the K2 based software as well. What also K2 app enables you is, for example, price estimates. You don't need to sometimes, especially if you're in the beginning or in the beginning of the negotiations with your customers, your clients, calculate everything in detail and you want to give them a quick price. The K2 app, you know, has already, you know, estimated prices inside that you can look them up and price the mounting system for your clients. It also, K2 app also enables you to navigate through and, let's say, show customers assembly instructions or show them a quick brochure on a certain product. So there's a lot of things, you know, where K2 app can usefully help you. So I suggest now we hop into our exercises. So I'm going to open a new project here. I'm going to enter my address from a project that I have received this morning. It was, by the way, in Croatia. So I'm going to do this project with you. So cool thing about the K2 base is it's Google Earth supported. So you always, you know, you have to know the address, location address, and you're going to enter, and it's going to lead you to your project. Another thing I want to point out too here is the expert mode, which basically means, you know, expert mode is going to require more information, more detailed parameters about your project, about your rooftop, about your building, than if you have it turned off. So I'm going to leave it now turned on as expert mode because I want to, you know, enter all the parameters. So this would be, I'm going to enter now the data. First data, exercise number 1. It's going to be trapezoidal metal sheet, which is one of the most prevalent, you know, common roof types in the area of commercial and industrial buildings. Quick note on the design method. So we in Europe, we have over 50 participants today for this webinar, Asia, Europe, America. In Europe, we use the Eurocode norm. So it's the standard for the design method based on which we calculate our project. Of course, certain countries have the national annex to it. For example, DIN EN, this would be for Germany. I know BSEN, this would be for the UK. So, a lot of countries we already have inside the national annex to the Eurocode, but where you don't have them, you'll have to, at a later stage, manually enter the values, especially for snow load and for the wind speed. Let me show you quickly how it looks like. I'm going to choose a country as an example. This is, for example, for Lithuania. This is pretty much the data that you have to, at the later stage, enter manually because you don't have it saved in our software yet. So they have 3 regions for the wind speed, from 24 to 32 meters per second. And they have 2 regions for snow load, so 1.2, 1.6. So we're going to do the Croatian now project. I'm going to need this, wind speeds for my project, so I'll have to read it off and manually enter the later stage. But however, some countries like Germany and many others, they have already this saved. You can, here enter stuff like the client. In this case, it's not so important, but make sure you enter all the data because it's going to be easier later on to find the project when you scroll back and look them up. You can, of course, zoom in your project. Sometimes the resolution won't be so good, and we will do then the K2 base 2D view. I'll show you in a minute how you do it if the resolution is bad, but I suggest we just hop into it, and we have to now start with our roof. So we are at the roof section over here. We start by adding our roof. So we want to first mark the areas where our roof is, where the PV modules will be placed on. And you do that by adding roofs by clicking on plus. Let me tell you, so you can add as many rooftops as you wish. So that's no problem at all. So if you click plus, then your first task is to select the roof type. We are obviously dealing now with the gable roof, which is a double pitch roof. You also have a possibility of a mini pitch, mono pitch roof, and a flat roof. So my roof is at the moment a gable roof. It's pretty symmetric, in terms of shape. So I'm going to use the triangle, and I know that for my somebody has already made the building survey. My roof is trapezoidal metal sheet, and I'm going to calculate one project with our speed rail system, which is one of the best sellers at K2 in Europe. So it's pretty easy to install. It's only attached with self-tapping screws to the metal sheet. So I'm going to choose this, and I'm going to add my roof. So first you need to click, and you need to drag with the mouse along the roof length. I suggest you always drag first along the longer sides of the roof, which is in this case the length, and then you drag down, and you did, this way designate the area where your modules will be. Now, so this resolution is pretty good. You can see the Google Earth image, very well. But you will have projects, where you will not be able to see, the image very well. It will be of poor quality. In this case, we have here a function called switch to 2D view, and this will give you a much better, possibility even to enter the measurements of the roof and see the modules at the later stage more clearly. So you can also here, change, for example, you can enter the exact measurements of the roof. Let's say I need 41 meters, and I need, for example, 9.2 meter in terms of the width. I switch back here, and you see a little arrow here, which basically means the orientation of the pitch. That's incorrect. You have to correct that by clicking either on minus or plus, and making the right roof pitch orientation, which is downwards in my case. So because this is double pitch roof. What you can also do here is remaining the roof. Let's say that your roof number 1 is a warehouse. You can also do it here because you have several projects and you have several rooftops for the same project, and you'll make it much easier for yourself to find the rooftops if you have 10 later on when you reopen the projects. What you also can do here is you can delete the whole roof that you have just marked, for example. We don't want to do that, but just to show you. Another cool function, what you can do here is to copy or to duplicate the rooftop. So I'm going to do this just to show you. I have just duplicated my rooftop, so I don't need to redraw it again and use the same procedure by adding rooftops at the moment. So I'm going to just delete this one because we won't need it for the sake of the exercise. One rooftop is okay. Now I'm at the stage when I need to, start entering the parameters. K2Base is an excellent tool, excellent designing software, and it works perfectly as long as you feed it with the incorrect data. I mean, you still have to make your homework. We have to make our homework, do the building survey, because the software actually doesn't know if we're feeding it with the correct data or with the incorrect data. So basically, if you're an installer, you have to do the building survey in order to be able to enter this data, because if you do it by heart or if you feed it with incorrect parameters, then the installer actually installing this mounting system, which will be calculated, will not have the real-time circumstances. The calculation and the document printout won't be in agreement with what's gonna be the case on the rooftop itself. So these data have to be really 100% accurate. So my building height in this case would be 11 meters. I have 25 degrees in roof pitch. I have already corrected here the roof pitch orientation, and I already have decided, based on the project, that my rooftop is made of trapezoidal metal sheet. I also have the possibility here to choose how I'm gonna, perform my fixation. I can do it either to the roof covering, so to the metal sheet itself by using self-tapping screws, or because I know it's too thin and I cannot do this, first option, then I'll opt for roof construction. This means, going into the understructure, into the purlins, battens, whatever you call them. In this case, I would have to choose and opt for roof construction. But since I have, decided to show you today as a first exercise, one of our best sellers, which is speed rail, I will just use, fixation attachment to the roof cover itself. So this is here. My next parameters that I need to enter are roofing characteristics. First of all, we have here the crest distance. Cool thing, for those who are encountering K2Base, if you don't know yet what the crest distance might be, you can click here on the question mark, and it's going to guide you through and tell you the answer to your question. So what is the crest distance? Is actually the spacing between these two ribs. In my case, this would be 250 millimeters. The next parameter is also quite important, would be the crest width. So for those, let me on a quick note tell you, here is the crest width. So this is very important for speed rail. We need, a certain width so that our element, which is called the speed clip, can perfectly sit on the crest. In my case, that would be 25. Crest height, so that's another parameter. which is more important if you choose the fixation into the understructure of the roof. So is the height right here. So I can leave 40 because this is not crucial for me at the moment. Very important, this is quite crucial when you are opting for solutions, say, attaching your construction, your mounting system only to the upper metal sheet, would be to choose your material. So in my case, that would be steel. You have also the possibility of aluminum. Steel and aluminum for trapezoidal sheet are mostly common. However, to perform this solution, with speed rail, or we have also mini rail in our product portfolio as an option for the fixation into the metal sheet, you need certain thickness. That's why it's asking you what the thickness is. So my suggestion is that you do, these kind of solutions if you have for steel minimum 0.50 millimeters in thickness, and for aluminum at least 0.7 millimeters in thickness. That's my recommendation. If you have less, if you have done the building survey properly and you have measured the thickness, you have less, then you would, my suggestion, my recommendation would rather be just going to the understructure. So we're pretty much done with, entering the parameters. What you can also do here is, add some obstructions. Many times you have on the rooftops, chimneys, AC devices and whatnot, and you can all add them here. Let me do this. So I'm going to choose a rectangle by clicking over here. Here would be my polygon, an asymmetric shape of my obstruction. I will choose a rectangle, and I'm going to do one obstacle for you. So same procedure as it was with the, marking the roof area. So clicking and dragging and double click to fix it. Our software is at the moment working. What I can also do here is adding my height. So let's say that you have a chimney or AC device. Height is quite important because, we have a possibility here to show you shading. So in case you don't use, for example, solar optimizers, at the later stage of design here, we're going to see which modules are going to be pretty much shaded, and we'll be able easier to see which ones must be deleted, right? Because you have here the worst case scenario, 21st of December, and you can easily here see where the shade is. What you can also do, if you have several chimneys, you have several obstructions, you also can duplicate these by, clicking over here, and you can, play with them as much as you want. You can add them, duplicate as many as you wish, and also switch back to 2D view. If you have bad resolution, you can also change here, your measurements of your obstacle. So let me do this quickly and switch back over here. So I have now 2 obstacles. For the sake of the exercise, I think it's okay. So we're pretty much, done with this step. I suggest moving over to the next step, which would be the design. Oh, one more thing, guys, I have just forgotten. So here, under the obstructions, you can also say, minimum edge distance. And I will say, dear software, make it 0.3. So that's up to you, but anyhow, you're going to see shading of PV modules at the later stage when we go to the design. So the design phase, the design stage here actually enables you or requires from you adding the PV modules, placing the PV modules on the designated area, on the marked rooftop that you have decided to be your area. We have pretty much all, module manufacturers saved in our system. If you want to look up a particular model, you have to start typing in, and then it would pop up. It would offer you one, and then you would have to then choose a model, a product category from the drop-down list below. If you cannot find it, then you can user define it over here. You will just type it in, enter the dimensions of the PV modules manually. So right here. When you go to the module array, this is basically the module block. This is where you will be starting placing PV modules on your rooftop. And it's again same function, so you use the plus button here. You can add as many module fields as you wish, so don't worry about that. I have already decided I'm going to offer for this project the speed rail solution. I'm going to show you in a minute for those who haven't, been familiar very much with our mounting system, how speed rail looks like, and how you install it. Let me choose speed rail. The next thing you have to decide about is, dear software, I want you to cover complete roof with PV modules or a particular module field. So either way, the software is going to help you superimpose the PV modules on this rooftop. So I'm going to choose, first of all, to show you how to do complete roof. And for speed rail, I'm going to opt for portrait because I know that this is easier and much faster to install than if you opt for landscape. For almost each mounting system, we have a rule in terms of whether you need to go portrait or landscape, what is cheaper, what is easier and faster to install. And you need to explore this a little bit, before you decide, before you plan this, before you design it in your software, what would be the best solution for you. For me, and for the sake of this exercise, I will choose the portrait format. So let me do this, and the software will do the work for me. Let's go back here. So this is my first rooftop, my first, PV module field. Again, you can, here you have certain icons, functions in terms of what you want to do with this PV module field. If you want to delete it, again, delete the whole PV module field, you're going to click over here on this, big X, but you're going to delete the whole PV module field. If you wish to delete individual PV modules, you have to click on the rubber over here, and you can start clicking on them and start deleting them, right? I have now just selected 6, and then I have to click again on the rubber to make them gone. So if you want to undo what you have just done, then you basically click again on the rubber. So sorry for that. You click back on them, and they're back. You will have also projects when you will have, say, 500 PV modules, very big industrial, large scale projects, and you have to, delete rows and whole columns of PV modules. In this case, this you will do with Control button on your keyboard, or if you wish to delete the whole row, then you'll do with the Shift and your left mouse click. So these are the type of, deleting methods that you could apply when you have to, get rid of certain PV modules. So in this case, I'm going to put them back on. So we see here very clearly, the shading, and we know, or we clearly see which PV modules we have to delete. Like I said, unless you're using optimizers, and you don't need to delete that. So what you could also do, so I'm going to now close this rubber function when PV module is back over here. Close the rubber method. What you can also do, you can copy several module fields, as many as you wish. So you do this by choosing the icon over here. So basically it means, you know, duplicating the PV module field. So let me do this at the moment. I'm going to move on with my presentation. I will get rid of this module field. I'm going to do two fields for you to show you also the module field function. So in this case, you also have to designate the area again. So I'm going to make two, just slightly up to my obstacle, and I'm going to add another one. So it's already selected, and I'm going to do another one over here. Right there. Yeah. You can, you know, at the later stage, you can, because we have several solutions or options how to fix this system to the trapezoidal metal sheet, you can still at the later stage change the mounting system of K2. This is done here, the drop-down menu. What you can also do at a later stage is also to change the module orientation. Let's say you change your mind and you wish to switch to the landscape mode. So you can also do this now. So this would be for field number 2. And if I go back to the module field number 1, I can do the same. So yeah, so now it's changed, and you know, you can do this right here. I'm going to change it back to portrait. As I mentioned, it's easier and faster to install. Then you have the drop-down menu. Here you have several options like module clamps. You know, you can choose our first generation clamps, or let's say our universal one mid, one end option. So I would just stick to our universal clamps. Another issue that's very important in the world of mounting systems are the thermal separation rules, so the thermal gaps. You all know that, you know, aluminum is expanding when heated. It has the temperature coefficient roughly twice of that of steel. So when heated, it does expand. That's why you cannot infinitely join rails. You know, you have to, after a certain point, make a break and then continue joining the rails. And this is pretty much what thermal gaps means. In my case, let me, you know, make it a little bit bigger for you here. I have the thermal cut over here in my first module field, and another one over here in the second. This one is pretty good. You know, our software already knows automatically when each system of K2 you need to break, you need to separate after how many meters, and it's already automatic. And because it's automatic, sometimes it's not optimal how it cuts off a certain column of PV modules, or, you know, a row of PV modules. You know, for my module array number 1, it's okay. It happens to be okay, but here I will have to optimize. So here I will optimize. The software works automatically. It just cut through this column, leaving, you know, my one column of PV modules alone. So, you know, as a general rule, please strive to make blocks of PV modules or fields of PV modules which are equal in size. From, you know, in terms of stability, it's much better to have symmetric blocks of PV modules in terms of the size. So I'm going to optimize. I'm going to leave this one as it is, and I'm just going to optimize the thermal cut of the second module field a little bit. So you do this by editing. Basically, in the vertical direction, I don't need to do anything, but I have to do them in the horizontal direction. I have to optimize this one. And you can do this, you know, by clicking on this line where you see the thermal gap is, and you have to unclick it. So you make it gone. And I decided to have it, somewhere here in the middle to make it more symmetric. So let me click on edit thermal gaps again. The previous one is still here, and I'm gonna get rid of it now. So it's right here. Now I have pretty much, two equally sized blocks of PV modules, and this is what the idea should always be. Don't always let the software do this automatically, and sometimes you'll just be forced to optimize this. So I'm pretty much good, with both. So I'm satisfied they're both symmetric, and I'm pretty much done with this step over here with the design. Just down below here, you can, double check again, how many PV modules you have and the power. This is pretty much everything what we have to do in terms of the electrical or energy side of the PV business. So because we're dealing mainly with the static structural side of the mounting systems, and of course the mechanical side of the mounting systems. So the next step would be the loads. As I previously mentioned to you, like certain countries already have the national annex in our system, in our software. In this case, I'm calculating this in Croatia for the client. I need to enter the loads manually. I need to do this manually. What I need to enter is, of course, the basic wind speed. I have to also select the terrain category. Tell you in a minute what that means, how does it affect the load. And I also have to enter the snow load over here. And that's snow load on the ground. Snow load on the roof, based on the parameters like roof pitch, will be calculated automatically by the software. So don't worry about that. So I have to, read it off from the map because, I don't have Croatia inside the software yet. My project is around here. I have around 21 meters per second in this area of Croatia right here that I have to enter. I'll do this in a second. 21 meters per second. Very importantly, terrain category. This is crucial, that you are accurate when you are selecting the terrain category. The terrain category is pretty much the micro location of your building, of your project. So, you have 5 options here. From coastal region, which is the worst. So your building would be mostly exposed on the coast. You have the possibility of choosing lakes, plain fields, villages, suburbs, and woodlands, and urban areas. So the more you move up from the coastal region to the urban areas, the more it will affect, the final wind load calculation, which will be calculated by the software itself. So this project is not in the coastal region. It would be 0.77 kilonewtons per square meter if it was on the coast, but it's not. So I know if I go back on my project here and zoom it in, I see it's pretty much situated in the middle of the field. That's why I would select here the the plain fields. So my direct load, which is calculated by the software, is automatically lower. That's why it's so important. I cannot emphasize this enough that you're very accurate, entering and selecting these parameters. So this was in terms of wind load. The next thing I need to enter and read it off from the map is my snow load, because again, it's not in our software. I know because I have already done the project, it's 1.2 kilonewton per square meter. And I also have here the possibility of choosing like open terrain, normal, or protected. I would just here choose open. It's pretty much open. And there's another function here that you can click on if you know that your roof has a snow guard or several snow guards. It would affect the snow load on the roof. In this case, it wouldn't, because the roof pitch is less than 35 degrees. But if you have like very high slopes above 35 degrees, in this case, you know, the direct snow load on the roof would be a bit higher, you know, because the snow would be stable on the roof. In this case, it doesn't change. So we are pretty much done with the loads section over here, and we can move over to results. This is where you will, guys, you know, get the most important, the information whether your system is structurally verified, if it's strong enough based on the circumstances, based on the loads and the parameters that we have been entering so far. Here, before we check this by verification system utilization, you have the option here to select our standard rail length. The red ones are previous generation. I'm just gonna click on all of them. Then you have certain items, you know, dealing with electricity, like lightning protection, TerraGriff, cable management. You might want to discuss internally whether you want to, you know, select this, you know, purchase it from K2, or you have other sources. So you also have the possibility to select this. Then you have a drop-down menu here of loads on modules. You know, this is for more sophisticated users. Not everybody needs that. It's very detailed and very in-depth for engineers. So the engineers will perfectly know what this means. And here is our verification system utilization. So that's a confirmation. We have verified this project. The chosen mounting system is strong enough. It says everything is in order. You have to be green here, and you have to also check certain section over here. Fastener in this case means the screws. Also, the rails are important. With these percentages, you know, you have to be under 100%, because if you're above 100%, let's say that you land at 110%, it means you would be 10% overloaded. So this system would be too weak. You would have to choose another stronger one. But in this case, we have managed to verify this project, and we've been given a green light basically. So, you know, on a quick note, you know, the rails themselves will very rarely be problematic in terms of the stability. If you won't get through and not be able to verify the project, then usually it will be the fasteners. In this case, the screws, and in terms of roof hooks, the roof hooks themselves. So, but not so often, in my experience, the rails themselves. So mainly you have to look at the fasteners. So that's it. We're good to go. The last step is the summary, and this is where we get the material breakdown. So the specification of material. We have here everything: the item number, the quantity, the weights. You can check again your quantity, or number of PV modules, and you can also approach this lens. If you click on the lens or just approach it, you're going to see which element has been specified in this specification. So you can also edit this bill of material. You click on it and you say, I don't know, I want to add a couple of more rooks before I order to K2. Then you can do this as well. So you're going to have to enter the item number, and the searched item, it's going to pop up, it's going to offer it to you, and you're going to just then enter the quantity. So this you can also do. What you can also do is just delete certain items like this, and then you would apply here. So you can do many stuff. So this specification you can also export to Excel. Let's do this quickly. So this is our specification, ready for order, I would say, because the first column and basically the third is basically everything what we need for order. So this is a specification ready for order. Also, what's also important is the document. So this document and this mounting system has been verified in accordance with the Eurocode standards, and you can generate the whole document right here. You can click on it and you'll generate the PDF document. It's gonna pop up in a second right here. So this is the document. It has 12 pages. Just gonna enlarge it a bit here. Project name, author. First few pages is pretty much what you have been entering so far. So we have entered the location, we have entered the name of the project, then we have entered building parameters and so on and so forth. Of course, the loads, the wind speed. This is the document for the speed rail. Here we have also the assembly plan. In our case, we would have 3 types of total rail length. So I have type A, which is 8.2 meters, and it's basically a guideline for installers how to install these and combine different rail lengths. 4.3 meters is our standard length. You need 1 piece, but to reach this length, you're going to cut down to size another one of same length to 3.9 meters. So this is pretty much a guideline how installers should do the cutoff. And here are the leftovers, basically. We have 3 rail length types. Here, on a quick note, here is a legend, what certain elements mean. This blank square is a speed lock for those who have already installed. You know what it is. Fastener is pretty much the speed clip. This blue line will be the rails. So if you scroll down a little bit, you have your layout. This could be, this document could be also handed over to an installer as a printout so they can use it at the job site, help them how they should install this. Let me, rotate this a little bit. Just gonna enlarge this a little bit for you to see what I meant with the type A. Here is type A. So how you combine the rails together, how you join them. The installer would also see right here, there would be a thermal cut they would need to do. So very importantly. And here would be, if I enlarge it further for you, you can maybe see it, a type B rail length. So this would be over here. And then you have type C. So this is what we have previously already mentioned. So I'm gonna rotate this back. Scrolling down, you have now a lot of, detailed data calculations, not for everybody, not everybody needs that. That's more or less for structural engineers, or, engineers per se, they will know what these parameters means, but they're very in-depth. Not everybody needs that. Then, towards the end, you have structural analysis report. Again, the data that we have been entering and a lot of detailed information and in-depth calculations. This is a structure analysis. So for very sophisticated users, the system has been successfully calculated, very importantly. And the last page would always be for you guys, the bill of materials. So this is how a verified document, a verified mounting system, if you will, looks like. It's very important to make it. So this was the first speed rail. This was the first system with the speed rail. Let me navigate a little bit to the website, show you our website. a quick information about our speed rail system that we have just calculated. I encourage you to, use our website. It's very easy to navigate through, very clear, a lot of information, about our product, about our company, profile, locations where we are located. And you also have the certificates, for example. You can find them here. I get a lot of emails from you guys, send me this certificate, send me that certificate. I'm willing to do that, but many things like certificates you can also find over here, so on the website. Then you can find information about your project. You can contact our support here. Very importantly, so again, the webinar schedule, would like to point out to it again, because many of you couldn't book today's webinar or the Friday's one. Don't worry, tell your colleagues they could, sign up for the webinar in the following weeks. There will be many. So also for colleagues and clients that you would like to encourage to use BASE, the software. So this is where you can actually register. The checklists, so the checklists are also here. Let's say that you have you need a customized solution. You have a special roof type and you cannot calculate and design it in our K2 BASE system. In this case, customized solutions we would do for you. We would calculate it for you, but we would need a filled-in checklist with all the parameters. We need to know everything, and we can then spec it out for you. So we have here checklists for different roof types. So down here. What else you can find? You can find news, technical information about our product and contact. So I'm going to show you the product information for the speed rail because we have just calculated it. And I'm going to open the section of trapezoidal sheet metal. So here we have several solutions. And you can find the speed rail down here. It's a drop-down menu. So you can find, all information about the particular mounting system from product data sheet, brochures, accessories, checklists again, and assembly instructions. So we have several languages. So I would choose, for the purpose of this presentation, the English version. Let me show you how our assembly instructions are structured. Hope everybody sees that. I'll make it slightly bigger. So this is speed rail system attached to the upper metal sheet only. Luckily, we have our partner has made a building survey, knows it's possible. We have the right thickness to perform this with self-tapping screws. As I mentioned earlier, if you don't have the thickness, you would normally want to go inside, so into the understructure. So our assembly instructions for all mounting systems are structured pretty much the same way. First, you have some general safety information and the following guidelines. And then it starts step by step, with the assembly procedure. You would also have with each assembly instruction the overview of items with item numbers. So it's quite easy to navigate through. So step by step, you can explore our website and the mounting instructions, the assembly instructions that you need, and you're going to see it's very easy to see how to install a particular mounting system. So K2 BASE is a great tool if you already know how to use it and you know a little bit about mounting systems, which ones you prefer, which ones would be price affordable for a particular project, depending on several factors. Then you choose during your design in the K2 BASE software your preferred mounting system, because the truth of the matter is, for one roof type, we might have 1, 2, 3 or more solutions, that are slightly or completely different for a particular roof type. So it's of course great to know what you're looking for. So because I'm I have to hurry on. I have spent a little bit more time on speed rail. I have to move over to the next example. The next exercise would be, I will open it from my projects. I have already prepared number 2 flat roof. I will do a flat roof now. So I will open it. This one is from Germany. Now the world of flat roofs and flat roof solutions is a little bit different than the pitch roof solutions, because these flat roof solutions are not fixed to the rooftop themselves, but they're ballasted. So in the results section, what we are looking for is basically the ballast calculation beside the stability. And this is, the main difference between the pitched roofs and the flat roof mounting solutions. So I already have the address inside. I have already made the first step. I have filled in the first step, and I'm moving over to the roof section. I hope, guys, you have questions. My Alessandro is working in the background, replying to you, because we have over 50 participants. There's also a lot of questions, and hopefully, if we don't manage to reply to all of them, we will do it after the webinar, so none of the questions will be left out. So let's do an example with flat roofs. I'm gonna here mark my roof. It's a flat roof. As an exercise, I will use polygon just to show you how this polygon works, and I'll have to do membrane roof. So right here, I have to add, and I'll make a quick roof area over here with polygon function. You have to go point by point and click each and every point and move over. So pretty much what I'm doing now. Okay, so I would like to switch to 2D view because this is maximum where I can zoom in. So this is my designated roof area. Like I said, you can change it here and confirm it with enter, the exact measurements. And I'm going to go now here to just enter the parameters. So my building height is 11 meters. I'm working with 1 degree roof pitch. For those who are new to the flat roof solutions, the world of flat roof solutions, sorry. You have several types of membranes that these rooftops usually have, and the most prevalent, the most common, I would say 90%, would be the PVC membrane, which is a polymer sort of thing, and also the bitumen-based ply membrane. And I know this is a bitumen-based membrane, so I have to choose that. I would also like to choose this, change the slope. It's downward, so I will do this by plus, clicking on plus. Very important is the parapet wall height from the standpoint of the ballast calculation that we will get in the end here under results. And also the friction coefficient, I'll get that in a minute. I encourage you to enter the building height very accurately. Building height is crucial for the ballast calculation. Higher buildings tend to have much higher ballast calculation, so you will see a big difference between a roof which is solely 5 meters high compared to the one which is, I don't know, 15. So these parameters will crucially influence the calculation of ballast. So I encourage you to do these first steps very accurately. Friction coefficient. I would like to ask my colleague Alessandro in the background to send to all participants the short video how to measure the friction coefficient. It's a very straightforward method, very easy to do. Takes about 5 minutes. Of course, you have to drive over there to the job site to do it, but it's also very crucial in terms of the ballast calculation. So these friction coefficients influence highly on how much ballast you're gonna have in the end under the result sections or so. We know only the averages, you know, but since you have so many manufacturers of different roof membranes, then it's hard to know exactly how much you need to enter. We know, like I said, the averages, but we encourage you, each and every one of you, to, you know, just measure this each and every time. I will take an average. I have measured this in the past. So for bitumen-based ply membrane, I would enter 0.65. It's, you know, the average, but it can swing back and forth like, you know, 10 or even more. So depending on the manufacturer and the type of the bitumen-based ply membrane. So for the sake of the exercise, I'm just gonna leave 0.65. Again, now here we can, you know, add another obstruction quickly. I have shown this already, so I wouldn't here complicate and take up too much of my time here. So under remarks here, I don't think I have mentioned this. When I was calculating speed rail, you can add some notes, like because you'll be saving these notes, and, you know, you'll be reopening your projects after a week, and you'll see the remarks, what you need to double check. Say you need to double check a parameter that you currently don't know right now for this calculation. So double check the building height or something like that. So this you can do by remarks. So our roof section over here is pretty much done. We have chosen an area where we will have our PV modules, and we can move over to the design. So we will do the same procedure as we did previously with speed rail. I already have my PV modules inside, so I won't like re-enter these dimensions. And I will now add a field of PV modules. So we have several solutions for flat roofs. These are all standard solutions. I encourage you to use standard solutions always. You know, for Middle East, they wouldn't do these standard solutions that we normally use in Europe. They use something else. But for like Europe and, you know, continental Europe, I encourage you to use the standard solutions. We have SROC, S-Dome, and D-Dome. These three, by the way, SROC was already phased out. We have still D-Dome Classic, S-Dome Classic. It's a continuous rails, continuous base rail. And these three are the new generation, the latest generation with a discontinued base rail. They're also wider base rails, and they have a better protection mats below the base rail. It's a new generation made of EPDM. You know, the combination, both coupled with the wider base rail and the protection mat made of PDM, gives you a much lower ballast calculation, so much lower ballast quantities. With this new generation of our mounting, flat roof mounting solutions, we have significantly lower the amount of ballast, you know, compared to our previous systems and also compared to competitors. I'm gonna, for the sake of the exercise, just use S-Dome V10 degrees mounting system, and I'm gonna do complete roof. Here it's elevated. You cannot even choose, you know, portrait because it's a standard solution, only possible with landscape orientation of PV modules. And here, of course, since it's a standard solution, you cannot even switch to parallel. I'm going to add this now. So again, this is my, you know, field of PV modules. What I can do here is optimize, of course, the thermal gaps. Again, it's not critical or problematic in the vertical direction, so I don't need to change anything here. What I would have to do here is I would have to optimize here. But since, you know, this is my the software calculates as one field because here it cuts through here. So we're gonna have only a field of 4 PV modules. You know, this would be a very bad calculation, a lot of ballast, too much ballast. So it's a very bad example. So I just maybe show you how much are these two exposed. So I have, you know, 2 blocks of 2 PV modules. And the idea should be that I have a bigger block of PV modules. So because they resist the wind as a block as a whole. And when you design, you shall optimize my recommendation that you form as big blocks as PV modules as possible. So this, you know, block will be now separate from these two, and I will get much better amounts, much lower quantities of ballast than over here when I have 2 times 2 PV modules. So let's check this out. I want to erase these two. I just want to show you as an example. As I said earlier, Germany and some other countries, they already have the national annex for snow loads and wind speeds inside. I don't need to change anything here apart from the terrain category. So in this case, you also need to know where your, you know, micro location or where your building is situated at. So I will leave it because it is actually suburban area. That's number 2 or 3. And I'll move over to results. So again, here we have the ballast calculation. You can see here, somewhere you have 0, and somewhere you have, you know, the ballast calculation, which amounts to up to 40.5 kilos. And of course, here is again much more than it's over here, because this group is much stronger. It resists the wind as a group, and these two as well. So here you get much worse values because you have only 4 PV modules in one group. If I change something, so let me show you. If I have a building which would be 18 meters high, how much would this change the result? So we had maximum, remember earlier, 40 kilos. I have to go step by step, move over to the results section. I have much more. So I had previously 40 kilos as maximum, which is over here, and now it has, you know, increased to 49. So this is how much, you know, the building height has influence on the ballast calculation. So this is very important, you know, to enter accurately when you enter the parameters. Again, everything is in order. Summary is here. We would generate the document same way, the PDF document same way as previously. Import our specification, the material breakdown into Excel, as well as the PDF document, which is the entire document. So this would be the document, very useful also for the installers. It would be very easy for them, you know, if they're handed over this document, how much and where this, you know, ballast should be placed. So let me make it a little bit larger, so hope everybody sees these values. Again, so the pretty much, you know, the document is structured same way as for speed rail, and with the last page you have then the specification. Very importantly, you know, these flat roof solutions are, you know, most likely will be very big projects because these are, you know, indeed commercial industrial buildings. So you have to deal not just with a couple of PV modules like here, but sometimes you'll have hundreds or even thousands. So in this case, you know, this ballast plan and the resolution of that wouldn't be very clear. all these values will be indicated very small. In this case, I encourage you, to use export to Excel the balance plan. So you can export the balance plan to Excel and make it there more clear, more visible. As I'm saying, this would be the case, with large utility scale project when you have 1,000 and more PV modules, when you cannot see the values very well because you have bad resolution on account of the quantity of PV modules, which is enormous. So this would be one option for you, how to easier indicate the ballast calculation for the installers. So I hope, guys, you have a lot of questions. Let me go back over here. I hope you have a lot of questions. We have over 40 participants still. We have done more than an hour. I would suggest we pause here. We are a little bit, over the time limit. And I would do the roof hook calculation with you, or one of the colleagues will do it with you. So we'll do it with you in one of the following webinars. I hope you guys, you've learned something new and that I have provided some value added for you, something new. I have tried to, show you all the aspects and possibilities designing the projects in our K2-based software. Thank you very much for your interest and your joining in the seminar, the webinar, and stay safe, stay healthy. Wish you all the best and your loved ones. Thank you very much, guys, and see you soon.